Hi, it's Moser with your final hint/tip on the 4C worksheet. This is for number 10. We've got some ridiculously sized pancake in Manchester, England, and of course we're placing it on an inclined surface, inclined at 31 degrees, and we want to know what the coefficient of kinetic friction would have to be for the pancake to slide down with a constant velocity. We'd also like to know the magnitude of the frictional force that's acting on said pancake. So first of all, of course, we have to understand the situation, and we've got our slope, our object, force of gravity, normal force perpendicular to the surface, and force of kinetic friction acting upslope. Well, remember, we've got three equations that we can use and abuse and rearrange and substitute. So we've got all those. We're going to start off by looking at the mu k equals Fk over Fn. Well, since we are looking for the coefficient of kinetic friction, it seems like we're going to have to use this. Of course, we don't have Fk or Fn. So we're going to go ahead to the y-axis, where the sum of forces on the y, since the pancake may be sliding but it's not levitating, is 0, and we know that that's going to be equal to the normal force minus the force of gravity on the y. Well, that means Fn equals Fg cosine theta, or Fn equals mg cosine theta. That gets us one piece of the equation that we'll need for our mu k equals Fk over Fn. Excellent. Well, now let's look at the x-axis. We know that if it's sliding at a constant velocity, the sum of forces on the x is also equal to 0. That means sum of forces on the x is equal to Fk minus Fgx. So Fk equals Fg sine theta. That would get us the magnitude of our frictional force alone, but it also gets us something that we can plug right in to this equation. And hey, that kind of takes care of it, huh? All right, happy calculating.